My name is Mac Binesh. I'm with DESA Business Unit at VMware. And this is Fred Schimsheimer, my colleague. And we're going to present the VMware reference architecture for 4.0 and View 4.5. So when do we start?
Okay. Talk to you in a bit.
So we have a little flow going on here, so we can build it up. And I'll do a little bit, and then Fred does a little bit, and then we'll do the rest of it together. So let's start.
Don't worry about it.
You guys want to read this one? No? No. All right, so here's the agenda for today. We look at the goals. What was the criteria for success for this RA? By the way, this material is already posted on our website. So if you go to vmware.com/view, not the presentation, but the actual RA documents, vmware.com/view, and you select resources, you'll see the documents all posted there. All right. So Fred's going to come back and do the RAWC tool. How many of you have heard of RAWC? All right, great. So Fred is the author. So you have a special guest here that can tell you everything about RAWC. And of course, RAWC is available for download if you're a partner. And there's no charge. And then we'll look at the different RAs, and we'll wrap up at the end. I have 3 mandatory slides that I got to go through, but I'll do them real fast. You probably have seen this in most of the desktop sessions if you've been to them. Essentially, it's the journey to cloud, if you will. It's building the infrastructure around that, enable the cloud, and then collaboration on top of that. And so, if most of you in your IT segments, you can feel the pain on the right side, right? You can never satisfy anybody with anything, and of course, SLAs are a problem. And you're not getting any more money every year, right? It's less and less to do more and more with less. So essentially, to get the experience, these are the layers that you need to go through to get to the cloud that you want for the collaboration among your users and other users. So here we go. So what was the goal? The goal was to try to get the best density. And RA essentially has 3 legs that you have to balance. It's the VM per core density, it's the cost per VM, and it's the user experience. In other words, application response time has to be pretty close to what you do normally in a legacy environment. Any one of them out of whack and you don't have a good reference architecture. So in our case, we're looking at workloads for task worker and productivity worker. And I'll come back to that in a minute. That's the starting point. Because that essentially creates the engine that generates the IOPS. It generates, hits all the bottlenecks. And of course, it's a balancing act between the user, what they do, and of course, how you handle the capacity of the backend for various peaks and valleys. Of course, you have the boot storm, login storm, and steady state. And you do sizing based on those curves. 2048 was a number we came up at the end. We didn't set out day one saying that's the density we're going to achieve. We didn't know that. It was a lot of playing back and forth. We ended up actually developing a sizing calculator to figure out and do what-if scenarios. Because it's very time-consuming to do an RA, especially there's a lot of equipment involved. And it's a lot of investment, a lot of people involved. Actually, it was a team of about 10 people in this situation. And so you have to sort of incrementally figure this out, and eventually you have your target, and that's what you test against. It just happened to be, and I want to be upfront about this, that we're not here to recommend a particular configuration or a particular vendor or a storage or a compute server or one or the other. vSphere has all them certified, and you as a user need to decide which way to go. So we're going to present you generic data. What kind of processors, clock rate, how much memory, so forth and so on, how much IOPS you need, etc. Then you can translate that into your environment and figure out what kind of compromise you want to make. It just happened that we had access to this equipment in Santa Clara, and that's what we used. In the RAs, the link is right there. So in this case, I do need to give you the background why this equipment, what it can deliver. Basically, it's the middle configuration. Essentially, the chassis are UCS. The blades were Nehalem based using 2.93 megahertz clock rate, and we used 48 gig RAM. Essentially, each chassis has 8 slots, and you pick these boards and put them in there, and then you can extend it. So you have a linear scalability based on a tile, if you will. And this is a marking slide from VCE that kind of projects what the capacity is. The storage we used was Clarion in this case, and these are equipment actually in the lab. On the left is what we're using. On the right is actually a configuration with a high-end storage, which is the Symmetrix. And Symmetrix, that's not really something you want to use for VDI sizing. You're talking multi-million-dollar storage devices, more of a SAP, Oracle enterprise level deployments. But they were just sitting side by side. I thought I'd take a picture of them. So here's the breakdown on the hardware. I'm not going to go through this in detail. The slides will be posted in 2 weeks, and of course there's a lot of reference material available to kind of read that stuff. So right now I'm going to take a pause and bring Fred up to cover the actual tool we used to simulate these users. And so you probably want to get a better understanding what this tool does. And then we'll wrap it up after that. Here you go, Fred.
Okay. Thank you. Thank you, Mac. Welcome, everybody. Thanks for coming over to see the last session of the day. So I am the author of RAWC. I wrote this over a period of years, and we needed a workload to do VDI validations, and so I decided to go on that journey a couple of years ago, about 3 years ago. So what is RAWC? RAWC stands for Reference Architecture Workload Code. I couldn't think of a name, so I thought, what the heck? I'll just use an acronym. I'll just use the first letter of each thing, a Reference Architecture Workload Code. And actually, 2 years ago, I think it was December of 2008, when the first reference architecture came out. It was done by Warren Ponder at VMware, and he did the first RA, and I think it was just on 1,000 desktops, and that was it. And that's what kicked it all off. And then every other vendor and other partners wanted to get in on that and start using the RAWC tool. So we have quite a few partners now. We have several thousand people using the RAWC tool at this point. And it's available from Partner Central, and you can sign up for it, and you can download it. It costs nothing. And it comes with some other tools, which I'll touch on a little bit later. So let's talk about what RAWC is and how it works. So it's a desktop workload tool that generates a realistic and adjustable workload with all the Microsoft Office suite of applications. It also uses Adobe Reader, PKZip, 7-zip, and it does some Java compiles and does some builds. So we can use RAWC to break down the kind of workers that you want to simulate for a proof of concept. So let's say you want to look at a task worker, that somebody who runs 4 or 5 applications, somebody who's a knowledge-based worker, they'll start doing compiles and builds and compressions and that kind of thing, and somebody who's a power user. And we actually did quite a bit of studies with one of our vendors to figure out what a task worker was. So it was somebody who was between 0 and 3 to 4 IOPS, and knowledge worker, which was between not more than 10 IOPS, and power users are 10 IOPS and above, something like 20 IOPS. So that a power user would be somebody who's using, for instance, software chip design tools from maybe Cadence. Anyway, what RAWC does also, it generates log files, timing log files for open and close times on different applications, and we can use that information to figure out how many VMs per core you can get on a given processor. So basically, the bottom line of what RAWC will give you is how many VMs can you cram on a Nehalem or a Westmere or some of the x86 processors. So we gather the test results for CPU usage, memory utilization, storage, and networking, and I have, if you do a Google search on workload considerations, you'll see about a dozen reference architectures that were validated by different vendors, Dell and I think HP and EMC, and Network Appliance just came out with a really big paper. They just came out with a 50,000 seat validation, which is posted, I think, the other day, which is pretty incredible because nobody's ever worked at that scale before. And I would encourage you to take a look at that paper. That's pretty awesome. RAWC workload works, it runs on XP as well as Windows 7 32-bit and 64-bit. There's a 2010 version that's sitting in the wings, but we just haven't gotten around to it because of VMworld, so it'll be out soon. Let's take a look here. The way RAWC works, and we'll get into that in a second here, we'll look at the GUI. It uses a configuration file that's generated by the RAWC GUI. So when you download the application, it does an installation, and it comes up with a GUI that you can run on your laptop on a VM. You can run it anywhere. You can run it across the country remotely. And like I said earlier, it records open and close times in the applications, and it also has error log writing, so it can sense when errors are happening. So if you have overloaded systems, it'll actually tell you that. Remember I said it was sort of a realistic workload tool. Some workloads have canned applications that that have fixed scenarios, and RAWC does not. RAWC will actually let you set up a SendMail server, or we actually include a Linux server that has an IMAP server on it and SendMail, and it will send and receive individual email messages from a VM to the server and back. Now we've had a couple of vendors. I know Network Appliances are working on one right now. EMC did this and Dell did this. They stood up their own Exchange servers. They said, nah, Fred, that's really nice that you gave us this IMAP server. Well, we're not interested. We really want to stand up a Microsoft Exchange server and try it. And actually, that's how I developed the code. I actually used VMware's internal Exchange server until I was told to knock it off because the load was getting a little high. They were wondering where all the traffic was coming from. But that's how I proved it out. Some of the special features of RAWC are it's Active Directory aware. So that's really important. I was, as a good example, a good friend of ours that we worked with, he was saying, Fred, this is before I turned RAWC into an Active Directory awareness capability. They said, if you run this workload on 10,000 VMs, what's the point? They're all doing the same thing. He says, if you have 10,000 people in a company, are they all doing the same thing? No, they're not. So you may have engineers over here, you may have finance over here, marketing up front, and a whole office staff and sales and marketing in the back. So what you can do with RAWC is you can say, for a given Active Directory group, this user runs this. Because what RAWC does, not only does it have a listener on all the desktops, it also queries the group that you belong to. So how many people belong to an Active Directory group? See, let's see a show of hands. See, I can query that. I can query your Active Directory group and find out what you belong to. So if you belong to R&D or QA, or sales and marketing, I can find that out. And what RAWC will do is it'll say, aha, he belongs to engineering. And it goes out there, and it grabs that configuration file and brings it in. It says, this is the run template. And we'll go over that in a minute. So that's kind of the basics of that. The launch order in RAWC, there's a launch order in this tool as well. And the launch order can be random or static. Now, this is really important. Normally, people do different things at different times. So you're not all sitting at your keyboards running the same application like I said earlier. So RAWC can launch the order of the applications randomly. There's random number generators in the code that will launch the different applications at various times, which are spaced, which are also given application launch delay. So you may click from Word to Outlook, but you may not do it in 5 seconds. You may take 2 minutes before you do that, or you may not do that for 20 minutes. So I have special logic in there to work that out. And it's pretty random. I think when Network Appliance first looked at it, I don't think they believed it at first, but then you brought up a bunch. I think Chris Gephardt brought up a lot of screens, and they said, let's see if this is really random. And they did, and they discovered, geez, this is really random. It is completely random. And the static order is, and I'll show you that in a second here, in a few minutes here, you can actually lock down the order of the launch order. So if you're running Outlook, Word, Excel, PowerPoint, and maybe a video, you could say, I want it to run that order over and over again, and I don't want it to change. So you can actually stop it. And what I do is I zero out the random numerator generator seed order with a 0, and then we run like that. Application launch delay, so you can increase or decrease the workload, and this is important if you're trying to figure out how many VMs per core you want to get. And what you can do is, in the code, I have a lower metric in an array from a tenth of a second to an upper limit that you can choose yourself. And if you run applications randomly closer together, that increases the overall resource consumption on the ESX server or the vSphere server. But if you increase that delay randomly, it spreads out the workload across a period of time, and so that lowers the load. And so that's how you would get to a task worker. You could choose fewer applications and stretch out the delay, random delay between the applications, and that way you can put more VMs per core. We had IBM run this on the HS22 blades, and they were able to get, with Windows 7, 25 VMs per core on the HS22 blades and the Halen blades, but they did it as a task worker, so they ran 4 or 5 applications. But now for a power user, for a knowledge worker, they got up between 10 and 11, maximum 11. So you can see where you can, if you're trying to cost this out, and Mac's going to talk about this in a few minutes, how we can cost out VMs per core and how that translates into dollars at the end of the day, because people want to know, what's it going to cost me in the end? How's this going to work? I have a section here on the RAWC GUI for number of VMs under test, and that is to trigger a random start delay, because if you start 1,000 VMs all at once, what's going to happen to the server? I've actually had a customer that tried that, and you can do that, and the results were very predictable because everything died instantly when it tried to kick it all off at the same time. But that may also be a useful tool if you want to test out SSD drives, and Mac will talk about that as well later on. So you can actually create boot storms. And lastly, in RAWC, there's a thing called iteration and duration. So iteration is where you run various applications and they repeat. So that's an iteration. It may take 20 minutes, it may take an hour, depending upon the number of applications to select. And that's an iteration. It may come back around and start all over again. Now, what I put in the code was a tricky piece of software called duration. So you could say, I want to run it for 4 hours and that's it, and stop exactly to the second, and without killing the applications. So that was a bit of a trick. So what this will do is you can say, I want it to run for 4.5 hours and that's it, or I want it to run for 8 hours and clock it and that's it, or I want to run for an hour and 13 minutes. It will do it right to the minute, or right to the second actually. So it's very accurate. So you can actually put the workload into an iteration mode or a duration mode. And the reason I put in duration is because we had several customers that wanted that, so I worked on that. Let's see here. Here's the overall layout. We have a session launcher. We have the ESX server as the backend and the data store, a RAWC controller, and the email server, which I mentioned earlier, which you can throw out. You don't need it. You can use your own Exchange server. And the view connection server. So we have a witness layer and a launcher layer that launches the VMs, launches the desktops with the workload. Here's a picture of the RAWC GUI. Now, I wrote my own GUI in AutoIT, which was pretty complicated to write, but this is a much better GUI. It was written by one of the people in the professional services organization, and I think this is a lot better, actually, so I will talk about this one. So here, what we have, you can put in a test name that you want to have for the test description. You can put in a description here, a log folder, and you can actually choose your own log folder. You can also put in your email server. So you see how we have vdi-smtp2.rawc.local? That's what we give you. We can give you the IMAP server or the SendMail server that's included with the tool. Or you can put in your own IP address, or you could put in a name or something that's resolvable for your Exchange server. There's the launch order, random or static. And you'll see there the application launch delay. That's what I was talking about earlier. Right now it's set at 5 seconds, which is pretty aggressive. So that means between 1/10 of a second and 5 seconds, those applications are kicking off just like that very quickly. Normally when these RAs are done, they're done at 120 seconds. Launch delay, that's 2 minutes. That's pretty much been the standard for the last 2 years. Number of VMs under test. Right now it's set at 10. That's the lowest it can possibly be. It goes up to, I think right now, 5,000. Test mode, there you see the test mode, iteration or duration. So that's where you can say, I want it to run in iteration mode, where it will stop at some point by itself when you don't know where that is. Or you could actually say, I want it to run 120 minutes and that's it. So you can stop the test at that point. And it will cleanly close down all the applications. It cleans up the desktop, cleans up all the applications, and closes the log files and logs off. So it's very nice to have that feature. So here's the Active Directory group capability. It also can run without Active Directory. So if you don't click on the AD group, you can run it with or without Active Directory enablement. You can run this. You can run RAWC on view and outside of view. You can run it standalone. It doesn't really matter. You can see over here the number of emails. The number of emails are basically unlimited. It doesn't really matter. You can change the typing speed. You can change the number of random words you want to have. It has a random word generator in it. You can browse the number of PDF pages. There's actually more to what you see in this tool. There's actually a lot of hidden features in here, but if you want to know some of the other special features, we can go over that after the talk. And here you can see down here on the lower rows over here, you can see where you can pick your applications like Outlook, Outlook Setup, a couple of Word documents, random words, Internet Explorer, virus scanning, zip, Java application, race car, a couple of multimedia videos. And then you would save this test configuration, click on it, and then you would set it as active, and so you're ready to run. Let's see. I'm trying to think what other things we want to talk about here. Okay. Time checks. Okay. Yeah, so I mentioned something about timing logs. Now, there are ways to do various performance implementations. And I decided from the very beginning, I decided not to display what open times and close times are outright. The files are there, the timing logs are there for all the applications. And the reason is because it lends more credibility if I point you to a third-party vendor that can do that for you, such as Lakeside or Liquidor Labs. And Lakeside has a very good tool for end-user experience. So it can take those numbers. They use this tool, both Lakeside and Liquidor Lab both use the same tool. And they run those numbers, and they can tell you what the user experience is. So it's a function of, it's the reciprocal of the network latency delay plus CPU plus disk I/O, disk latency plus memory latency. There's lots of different issues, lots of different factors that make up this function. And Lakeside has a very good handle on that. And so I would recommend you use those tools. We actually, when you get RAWC, when you download this, we also bought the licenses for Lakeside and Liquidor Labs, which you can get for free. So you don't even have to go out and buy it. If you just go to our Partner Central, you can get the tools now for free as well. So not only can you get the tools for nothing, you can get the assessment tools as well. And it costs, so we have it all there for you. Let's see here. Okay, let's talk about actual workloads here. So this is where you can get it from professional services. And I'm sure you can get this after the talk. You can go to the website and get these. So there's a couple knowledge worker, task workers, and power users I talked about earlier, and you can make your own types of workloads if you want to. It's infinitely adjustable, so you can do whatever you want to do. You can say, I don't really like these workloads. I got the task worker, knowledge-based worker from Forrester Group, and I actually have a white paper on that. And so I pull these numbers not out of a hat. I actually did a lot of research on to find out what these different workers were, and I talked to different people in the marketing organization and said, what should we do? Actually, there's a PRD, which is a product-defined specification for RAWC that was written by Warren Ponder, and that's what I used to actually write the tool. So that is actually out there, and if anybody wants to see that, we can give that to you. Here's some of the workload definitions for a different profile, like a knowledge worker. So that's what you might see. This is as an example. Here's a crib sheet. This was used in VCE by Mac and myself in EMC in Santa Clara. And you can see the different Active Directory groups that we had here. And in this run sheet, we picked different applications. So for e-staff, human resources, finance, marketing, corporate, contractors, engineering. And you can make the same thing and make that crib sheet yourself. And I think, Chris, if I'm not mistaken, you have something very similar to that, except you don't use, there's one or two things you didn't run, but it's essentially the same kind of a thing. So that's what you can do. If you do this, now what you have is you have a company-defined workload here. So this is kind of, and you can, this is up to you, how you want to specify this. But this is what we used to run the VCE testing. Anyway, if you do a Google search on workload considerations, we have about 12 RAs right now. There's actually 15, 3 aren't posted yet. There's a new one that just came out from Dell. There's network appliance. I haven't got that yet, and there's a third one. I can't remember which it is. I want to say HP, but... HP, yeah. Anyway, now I'm going to turn over to Mac again, and he's going to go take a deeper dive, right, into...
Thank you, Fred.
The VCE stuff. Okay, I'm done.
Thank you for...
Thank you,
Great presentation, Fred. Okay, there's going to be a quiz after this, by the way. You should remember all this stuff here. So, all right, let's look at the 4.0. So the first thing you want to do when you build your environment is consider these parameters. Why is that? Well, because you got a base build image, right? A base image is going to generate your IOPS, so you're going to have to figure out what the workload goes in there, what kind of IOPS you're going to generate, what kind of container, guest OS you're going to run it on, and of course, then you have to figure out, front end, back end IOPS, and all that stuff. So be able to balance your environment. Now, if you use an XP, if you look at the box in XP, it says 1 gig or half a gig memory is what you want to define. Win 7, it's either 1 gig 32-bit or 64-bit, could be 2 gig or higher, And so that's going to affect your memory over commit. How much memory you put in on a blade. Memory, of course, is 4 DIMM versus 8 DIMM. And these are parameters, right? Because it plays into your cost factors. When we did this test, for example, the memory 8 DIMMs were about $2,000 a piece. 4 DIMMs, 4 gig DIMMs are about 400. Now that 8 gig has dropped to about 900 this time. So the cost keeps dropping. But at the time when you do this, you're going to have to figure all this stuff out. This was the configuration. So the test setup was top the clients. We simulated all those clients. We used the entire vSphere infrastructure on another set of blades to actually launch these clients. RAWC basically does that. And basically to connect to a connection broker coming in. And of course, on the left, you see the actual blades, the 16 blades that we were using. And on the right, you see the storage configuration. And essentially, this was our cost basis for this configuration. And here's the test setup for hardware and software. So for hardware, again, as I mentioned, there were 2 chassis. Each had 8 cores on them. These were Nehalem-based blades. And with 48 gig of memory on there. And then, of course, you had the SAN switch and the Clarion storage devices. I'll go into the actual configuration for the storage and how we set up the LUNs and so forth in a minute. The software-wise, of course, 4.0 with vSphere. And the VMs that we defined, it was a mixture of XP for knowledge worker with 1 gig RAM, and then for task worker for half gig RAM. So we had a percentage of, we initially started out with just half a gig, but then we decided normal environment could be a mix of the two. And there's different types of IOPS associated with them, as we found out later on. Traditionally, a task worker runs about 2 to 4 IOPS. Product worker generates about maybe around 8 to 9, 10 IOPS. Here's the storage configuration. We had the 15K fiber channel drives. We had 67 of them, but there's only 60 that can be actually used to create data stores. The other ones are for the operating system, the Flare software that actually manages the RAID controllers. We used a RAID 5, and as you see, we set up the LUNs to be totally balanced across both ESX clusters. We had actually 2 clusters of 8 blades each. And we ended up with 18 LUNs, all right? So we kind of balanced it across the 2 clusters, and we created those 9 pools. The 9 pools are those Active Directory pools that you saw on the crib sheet earlier. And that's what maps into those pools. And then, of course, when we provision those VMs, that will be across those pools, and we had a random number of VMs per pool. They're not equally distributed, but the pools themselves are equally balanced across the clusters. We had to use 2 connection brokers. In 4.0 architecture, the entire installation of Vue only supports 1,000 connections per broker. Now it's up to 2,000 connections per broker. So we use 2 brokers to achieve high density. So the strategy was to basically start looking at a single blade, do a scalability on single blade for VM per core density, and try to figure out if that's a linear scalability across the rest of the 16 blades. Okay, so we started testing, and trying to see what kind of VM per core density we're getting. We achieved about 16 VM per core. So on a single blade with 8 core, we're able to achieve about 128 VMs on a single blade. And then you multiply that, that's where you get the 2048 numbers across 16 blades. So the performance results. This is a CPU utilization. This is a snapshot of the steady state. We're not looking at the boot storms or the logging storm. But our goal was to keep it around mid 70% for CPU utilization, to have some headroom in case there's a failover of those 128 on a single blade to sprinkle across the rest of the 7 in a cluster. In terms of memory utilization, again, we're looking at 70% utilization at the steady state across each blade. And this is, again, a snapshot of one of the blades, but it's consistent across all blades. We got actually similar performance in terms of memory utilization. That means that our transparent page sharing is working right, because remember, it was a 48 gig of memory per blade, and we're doing 128 VMs are 1 gig and half a gig. So you're looking around 64 gig to 96 gig of memory requirements per 128. But with 48 gigs, so your transparent page sharing kicks in, you have some memory overcommit. But again, the utilization at the steady state looked with some headroom and capacity left within each blade. In terms of disk response time, we had 2 storage processors going to the Clarion, and each storage processor can handle about 8,000 IOPS per, so you have a capacity of 16,000 IOPS total. So in terms of response time, we're looking at somewhere around under 50 milliseconds for user experience portion. So it was cost per VM, VM density, and the user application response time. And here you can see that we're getting well below the 15 millisecond, somewhere around 7 to 10 millisecond for response time. This shows you the actual number of IOPS generated. So we're looking a total number of IOPS under 16,000, because that was our total capacity for both storage controllers. And you can see at the bottom, the SPA and SPB are the 2 on the Clarions. And so a combined 16,000 capacity, we're able to actually handle all the IOPS that were generated by these 2048 VMs across the 2 chassis. So 16 VM per core. Now, that's not something people are going to do in production. They might go with somewhere around 8 to 10 VM per core, but you have enough capacity. And of course, if you go lower density, you would see even lower thresholds on these graphs in terms of utilization of CPU and memory. But again, that depends on how much capacity and headroom you want left over. So in terms of results, again, 16 VM per core, that's what we achieved in that configuration for V40, showing it very scalable and providing a fairly good cost per VM in terms of CapEx and over the 2 chassis. So in 4.5, this is based on, of course, V4.5 and vSphere 4.1. We turned this whole architecture upside down. What we did was we created in 4.5, you have an ability to do tiered storage. So now you have all these VMDKs for base, image, link clones, for data, disposable disk, for vSwap, and you can basically assign and put them in different tier of storage. So normally you would put the base image in order to get around the boot storm on an SSD drive. So we decided, well, why don't we just put everything on an SSD drive and be on local SSD drives? So what we did was, these are based on the Halen processors. Again, what we did was we took SSD drives. They're about 160 gig a piece. And we put 2 of them, giving you about 320 gig worth of SSD storage per blade. Now what you're doing is you're creating linear scalability for both compute and storage per instance of ESX installation, or vSphere installation in this case. And you literally have very little latency because you're not going to SAN as much. Link clones are on the local storage. And SSD, just to give you an example, could generate or handle somewhere around 25,000 read IOPS and upwards of 4,000 write IOPS. Now, if you got two of them, you have an aggregate of twice as much, so around 50,000 read IOPS. Now, if you have, let's say, a 10 VM per core density, like in this case, this was a Win7 base, 32-bit with 1 gig RAM. Let's say you put a productivity worker workload in there that could generate, if it's optimized Win7, somewhere around 8 to 10, probably 12 IOPS. Multiply that by, if it's 10 VM per core, in our case, with 8 cores, you're talking about 80 users per blade installation. Now, 80 users could generate each 100 IOPS for a total of 8,000 IOPS and still have plenty of capacity on read IOPS by those SSDs. Remember, there are 25,000 each. So boot storms is a thing of the past. Composer, provisioning, link clones, it's instant because now you're writing to SSDs. Reset those VMs. I watched them when it was doing it. It just popped 10 at a time. No more waiting. So what you're getting here now, it's a non-persistent link clone desktop. That's what we call it. It's a stateless desktop. All right? Now, for all practical purposes, since you have all these IOPS at your hand, you could take the disposable disk and leave it inside the guest OS itself. You don't have to tier it anymore because there's capacity there to handle the IOPS. What you do, however, is go on the SAN on the right side for vSwap and put in your, say, roaming profile on a CIF share to be able to, and of course you can put your applications that are virtualized, the other two layers that you need to stream into the user's guest OS, right, to recompose his desktop as he logs in. Now, since it's a non-persistent desktop, it's a stateless desktop, well, some people ask, well, what happens if the SSD catches fire? What happens to a user? Well, when we tested it, I'm going to show you in a minute the utilization. These are actual hardware that we included, the Intel SSDs and 96 gig RAM and the switch. This is the storage we used, I'll come back to in a second, for the SAN and the software and the VM image. And we had another cluster set up actually for the infrastructure itself. But the point is, if the user loses their connection or a VM, essentially all they got to do is log back in. They get a new VM, basically. Everything else gets streamed back in there. When we did the testing with Win7, we're only getting about 40% CPU utilization on per blade. So you have plenty of headroom for failover and grabbing the VM and assigning it to another blade. Besides, these blades can be built very quickly, just a blade with 2 SSDs, and you plug back in the cluster and you're up and running. So what you get here is a CapEx that's going to give you a linear scalability per blade per specific number of users. You don't have to go and build and try to amortize your CapEx over 1,000, 2,000 users day one, because you're not going to have 2,000 users deployed day one. So the incremental cost per VM is almost less than $10 because you're now distributed among all these blades. Imagine if you have a branch office or a line of business, minimum investment to get 100 users up and running very quickly. What we found out in the Win7 environment, the bottleneck moves into the CPU. The cores become the bottleneck. If you're running an unoptimized version of Win7, you're looking at a much higher CPU utilization. That's what it's in our brief, somewhere around 70% at steady state. But when you optimize, it drops in 40%. What that means is that you can basically deploy users very quickly, have a good performance at lower cost per user, And incrementally, you can add capacity very quickly to those users. The SSDs themselves are not very expensive. They're around $600 a piece for 160 gig. If every SSD catches fire, for a 16-blade cluster, you got 32 SSDs, you're talking less than $20K per year, assuming MTBF is 0, and it catches fire every day, every one of them, every year, to replace them. So the architecture supports a particular use case where you can have stateless desktops and be able to provide all the layers to the user, but reduce the CapEx per user, be able to provide a much higher SLA in terms of provisioning, in terms of having the desktop available to the user. You can also, in some cases, you can also modify the timeout values on a session. By default is about 10 hours for a particular session. So when the user logs in and connects to a VM, if they disconnect, not log off, but disconnect, and they come back within 10 hours, they get the same desktop, essentially. So you get almost like a persistent feel to it, if you will, right? You don't get a reset of the desktop. That's some use cases that could be potential possibility there. So the use case, the bottleneck is in the core, is the CPU utilization. So if you move it from a 8-core Westmere or Nehalem to a 12-core Westmere, now if the ratios is 10 VM per core, now you're going from 80 to 120 users, right? Memory is not the issue anymore. The second thing that you have to worry about is the capacity on the SSD drives, because your link clones eventually will grow. In our test, we saw at a steady state about 2.2 gig per link clone. You can manage the growth using a refresh policy to make sure that they're in check. But as the SSD themselves, the drives are increasing capacity, 320 gig per drive will be available in a few months. And coming from vendors like Intel, where reliability is fairly high and quality of product, you can imagine 600 type gigabyte disk drive capacity SSDs sitting right on a single blade. The blade itself, Westmere right now, retails about $14K, I believe, with 96 gig of memory and 12 cores. Dell just announced a Dell, I believe, 910 that has 16 cores, and it was the #1 VMark benchmark in the 16-core category. I think AMD has a second one. There's a third one. I mean, that's a full, I think, it's almost like a server. It's not a blade. But it can have up to 512 gigabyte of RAM on it. And its starting price around, I think, 22K. So imagine the scalability factors and where the vendors are going in terms of adding SSD and increasing the number of cores. You're removing those bottlenecks in the next few months. And the scalability becomes even higher and higher. Imagine running Win7, 32-bit and 64-bit. I'm going to get to question and answer in a few minutes. But this is only the latency. I mean, you're removing the latency, essentially, for 80 desktops. This is just single blade. And you can see that initially, this is the unoptimized. This is the optimized Win7. And you want to do optimization, we have a document on our website where you can actually run this file, save it in a BAP format, and run it, get an instant Win7 optimization. Essentially, what you're seeing here is both read and write in terms of latency from the SSDs. And this is the optimized version. You can see there are some peaks here, but essentially you're getting such a low latency from these drives. So you're moving the latency on read-writes. You increase the number of IOPS for your applications. And you're also decreasing the amount of time you need to reset or provision additional desktops in the pool through Composer, because you're writing to SSDs themselves. So essentially, that's the end of the audio portion. But If you wanted to ask questions, there's a mic there, or you can just scream it out if you want. Go ahead, please. Yes. Yes. Right, so planned or unplanned downtime kind of thing. So if the drive, say, catches fire and there are 40 users on there, they basically have to relog back in because it's a stateless desktop, right? We just grab another one from the pool and assign them on a different blade.
I think his question is, what happens if you take that server down from there, for example?
What do you do? There's no vMotion here. There is no vMotion because it's link clone on local storage. There is no vMotion. So if you want to have the user, they just log back in, they'll be on a different blade, essentially. That's what happens. How do you define optimize? There are a list this long of registry settings. Turn off this, turn off that, do this, do that. You normally do it with a click, click, click. It takes you half a day to do it. In our case, we just create a BAT file or text file embedded in the PDF document. It's on our website. You download it and just save it as a BAT file, run that once, reboot your image, and you have an optimized base image. If you don't do an optimized Win 7, you're looking around 24, 25 IOPS for this scenario. Optimize, about 10, 12 IOPS. Your mileage may vary.
That's VMware's recommendation that if you're going to run Windows 7 and environment, you should set it this way.
Yeah, you want to optimize it unless you have, you have spare. I mean, you still have plenty of IOPS to capacity, but why waste it? One other thing, you may want also to turn on the prefetch capability within the OS. But there's also RTO acquisition, which is going to be included for the profile. So if you're using roaming profiles now, you want to move to our feature to handle profiles, like persona management is what we call it. Then you can also get more exciting because then it can do prefetch of the documents to the user after they log in. It can get rid of these registry collisions when you have multiple user collaboration. That's you have normally with roaming profile, the sizing issue. The other layer with the application, you can virtualize that and actually put them at a separate SSD so you can stream it really fast to the user, but essentially it comes in. Or you can put it inside the VM itself, but I wouldn't recommend it because it increases the size of the VM. So those are the tricks they can use. Yes?
The RTO?
Sorry. No, it's not included in the 4.5 product. It will be released. We acquired a company, announced it back in February. The problem is not that it doesn't work. It's just that the 4.5 train was running already. So it was a matter of regression testing. So it was pulled out, and it's going to be pulled back in. Yeah, it's coming, so. Yeah, that's part of the old strategy. I think this gentleman here. Very, very good point. We did announce that. It was at Steve's presentation. We dropped it down to 500, but that's for including licensing. 252 is the number. It's on our press release that hit on our website one day. So it's 252 is the total cost per VM, according to our retail number, for compute and storage and their share of the SAN per VM. So storage at both ends, plus the networking that glues it together, right? The Cisco switch. Those are the pieces that you slice and dice, and that becomes a 252 number. The only other, so there are essentially three numbers that you have to think about. There's a 252 for this components, the bill of material. There's a 250 roughly number if you don't have an SA with Microsoft to repurpose your PC, right? Then you would have to have a zero client or a thin client from Wise or somebody. That's your other number. We assume you have that maybe, repurpose. And the third 250 is a software. right? So I didn't want to break it down here, but that's where the 500 number or below 500 number comes from. Now, that's based on Nehalem. Remember, the density is only 10 VM per core on 8 cores. You go to Westmere, you have 12 cores. That number changes even more. Well, we don't want to talk about it right now because our full RA, this is a brief that we put out just this week, the full-blown data RA, the whole thing comes out by VMworld EMEA. That will be a few weeks. Okay, so this is Jason Campagna, and this is my partner in crime, Worldwide Technology. So that's where we did all this stuff. But go ahead. Was there other questions here? Yes. Sorry? These blades had 96 gig. So the VM was 1 gig 32-bit, and we literally had no overcommit because it was under 96 gig. We only had 80 VMs. 32-bit. For 64-bit, you could do 2 gig minimum. It's on the box. You have to pick a number, right, somewhere. I mean, you could do 32-bit for 4 gig if you wanted. Nobody can stop you from doing that. The problem, I'll get to you. This is an interesting point he's bringing up. We debated this a long time. Why would a person pick 32 versus 64-bit? Here's an answer that we came up with. When you go to Fry's and buy a laptop, or you want to upgrade your laptop, you buy Win 7 64-bit, it says, well, you got to have this and this and this, right? This much memory, this kind of CPU, and so forth and so on, to have an acceptable performance. So you have to go and upgrade something physically, right? But when you are a self-service portal, and a user goes up, right, and you're publishing these options to the users, saying here you can click this OS, or this OS. User has no idea what's going on in the back end. He says, wow, 64, I'm going to pick that. That's a better one. Sounds better to me. There's nothing to stop him. There's no roadblocks. So you as a back-end person needs to figure out. But the overcommit can take care of it. We've done this 64-bit 2 gig on Nehalem, on Westmere, and we could comfortably do a fairly good TPS, transparent page sharing kicks in pretty good. Even though ASLR is turned on by default in Win 7, which encrypt the blocks and so forth, so it affects the dedupe a little bit, but you can do a fairly good overcommit ratio, even with 64-bit. I hope that answered your question. There was another one there.
I just want to make sure I understood the storage architecture. So you're going on SSD on host, right?
Yeah, let me bring up the slide here. Go ahead.
Replicas on SSD on local host, and then shared, like let's say shared SAS is where your link clones are going, where the writes are going?
Yeah, so there are several VMDKs, right? There's the base image, which you do a snapshot, and there's a rep. Right, so link clones in the base image, if you look here, go on the SSD. Per SSD, you need a base image or a replica, right? Because you're distributing number of users per SSD. All right, so that's where it goes. The disposable disk, we left it inside the guest OS. We let that matter. You can tier it. We left it there, and Microsoft says 1.5 times the RAM, right, for the disposable disk. So that stuff is there. On the other side, what you end up with is the swap for vSphere, right? Has to be same as the RAM size on the VM. You probably never swap. And the user data, I should have changed the branding there, because some people thought, well, this is the old UDD, and now it's persistent, and you can't do for non-persistent. There's no UDD for non-persistent. That's not what I'm referring to. That's more of a roaming profile or his profile and that kind of thing. Now, some people, does that answer your question?
Yeah, I just want to make sure I understood the SSD being local versus shared.
Yeah, so the shared is on the left, SSD is on the right. So what happens, user comes in, logs in, he gets a replica, he gets his link clone out of this, and he's off and running. And then the mount point on a CIF for his roaming stuff, for your profile. You can even use an AD GPO to set personalization on it as well when he logs in, right? And then with timeout, you can, pardon me?
You're saying the user data is slow. They need the least amount of bias, the user data.
Yeah, that's, that's not the, latency is not there. Latency is the base images. So you first, yes, go ahead.
Oh, no, sorry, just referring back to RAWC. One of the things I didn't see was how you pick the logins. How does it, the user logins, how does that portion work?
Fred?
Running the workloads.
So how does it know? Oh, there's a session launcher. And so that logs into every VM that's under test. And the session launcher logs into all the VMs.
So just like a utility type?
Yeah, it's like a utility. And it's basically like one session launcher for 20 VMs. And I forget, Chris, how many did you run?
We did 100.
Yeah, see, they did 100. So their consolidation ratio was much better. So for 1,000 VMs, right, it's just 100 session launchers, and that does all the login for you automatically. Yeah. Go ahead.
The RAWC software that you came up with, is that something that you're using instead of the lakeside software?
No, it's in addition. So what RAWC does is just the workload tool. It generates the workload, and it generates the timing log files and the error log files, but the timing log files for open and close times of the applications. And what you can do with Lakeside and Liquidware Labs, they sit there and they watch the VMs. So you can drill down and actually look at all the processes on the VMs. So it's a tool that's in addition. So basically, it's the assessment. So what RAWC is, it's a workload generator. So it generates the workload, but you use Lakeside and you use Liquidware Labs to say, aha, this workload is doing this to these VMs, and we can actually drill down and see it. So that's what we recommend, that you use those two. Yeah, well, it's more sophisticated than a load sim, but yeah, it's even more sophisticated in the VSI logging consultants because it's truly
VSI is static.
It's static, it's all canned, and but RAWC is totally flexible and it's totally random. So so you would use Lakeside to say what's really going on with the VMs, and you can actually do the end user experience as well. And we also recommend Liquidware Labs. I think you're using Liquidware Labs, and Network Compliance is using Liquidware Labs. So both of these tools are very good, and they're free. So we bought the licenses ourselves. So if you want to run the proof of concept or assessment, you use RAWC, and you can get those tools and have at it.
Actually, I just want to follow up to Fred's point. One thing that we're thinking is if you guys have been around for a while, you know that when file servers were around, NFS file servers back in the 90s, people had fighting on performance numbers all the time, right? Mine's better than you and this and that. And then, of course, Lattice was the tool, right? Everybody bought into, and so that became a non-issue. So now the onus is on the vendor to actually come out and say, how I can do this. We're thinking, right now, that problem exists today. There is no standards committee or a body that says, use a tool that everybody buys into and there's no bias. So we're thinking maybe working on something to that effect to get everybody to come together on. Because that's an important piece of this puzzle.